Today we're looking at transforming a quadratic function. So we are going to write our vertex form one more time. Actually, we're going to write it a few times throughout this lesson. The more we write it, the more we know it. So it's f of x equals a times x minus h squared. Again, that's our cue that this is a quadratic with that exponent of 2 plus k. Color coding again. The three main points we're looking at here are A, H, and K. So I'm going to color code this for us so we can break these down. So you can tell a lot about a quadratic and what the graph is going to look like simply by breaking apart this formula here. A tells us two things. It tells us the direction that your parabola will point. So whether it opens up or down, and it tells us whether it is stretched. So that's when we see that parabola be, like when you stretch a rubber band, it gets skinnier, or compressed. When you squish something down, it gets wider, right? Stretched or compressed. Okay, H tells us whether our graph is going to slide towards the right or slide towards the left, okay? And the fancy math terms for that is determines the horizontal. Think of the horizon, right? The sun sets and rises. The horizon is that left to right. So the horizontal translation. And translation is a slide. So we're going to slide it to the right or slide it to the left, which is our x value, right? Your x is your walk on a coordinate plane. Okay, so our k determines the vertical shift. Make sure I spelled it right. So vertical is like columns, straight up and down. So now we're going to, the H tells us our walk, the K is going to tell us our climb. Is this parabola going to climb up or down? Translation, and again, that is a slide. We're sliding this around starting from the parent function. This is our Y, which is our climb. Remember, we walk before we climb. Okay. So let's look at some examples and be able to translate what this means when it's actually given to us in a formula or in an equation. Okay, so I'm just going to call this example A here, g of x. Remember, as long as it's in that function notation, we read it as of, and it can be g of x, f of x, y of x, it doesn't matter, it's still our y value here. So we have g of x equals negative 1/2 times x plus 2 to the second power. Okay, so a lot of times you are going to see me go above and I'm going to just like jot down this formula. Again, the more we write it, the more we know it. And this tells me a lot of what I need to know. So here we go, we have a times x minus h squared plus k. So I can already see I'm missing a k here. Okay, so let me get my color coding out here again. So our a is the 1/2. It's in the place of the 1/2. Make sure I don't mess up my color coding. H, I have pink here, and you notice in the H's place is a 2. Go ahead, bring that on up here. But you'll notice we changed our sign. So we're going to have to talk about what that means. And there's nothing in my K, so we can, of course, put a 0 there to hold that place value. Okay? All right. So I'm going to draw a graph here. It's not going to be perfect. It's okay, as long as I have some idea. So our parent function, remember, starts at that origin. And it makes this parabola. So it looks something like that. Okay? This is my parent function, which is f of x equals x squared. Remember, we always begin with that. You know, our family began with our parents before us, and then, you know, we were produced, and now we resemble our parents, but we might not be identical, right? So this is where our parent function lies, and we're going to transform this on the graph and see what our new function. I always call it like the kid function. What does this kid function look like? Let me change colors here so they stick out a little bit better. Okay, so we're going to break this apart. First, looking at, I always find my H and K first, but let's go ahead and do A since we'll like book, left to right. Okay, so my A value is -1/2, okay? Therefore, okay, this tells me two things. The negative tells me that the graph is going to open downward. It's going to be flipped on the x-axis here. The negative makes the graph open downward. Okay, and we'll say reflect over x-axis. It just means it's going to jump down below. Okay, let me break this apart here. So first thing it tells me is it's going to open downward. The second is, I'm going to add this, and will be vertically compressed. And how do we know that? Okay, and we're going to write this quite a bit as well. So a compress means that your A value was less than 1, and if it's stretched, it's greater than 1. So because, let's squeeze this in over here. If A is greater than 1, okay, that's a stretch. I'm going to use the word vertical because we're going to see that in class a lot. Vertical stretch. And if A is less than 1, as we see here, 1/2 is less than 1, it is a vertical compress. It's going to get a little fatter. Okay. So two things that we get just from looking at the value of A. Okay. Next, we can predict. So I already know it's going to be facing downward, and it's going to be compressed, so it's going to be a little bit chunkier, a little bit fatter than the parent function. Okay. Next is our H and K. What do our H and K tell us? Okay. H and K are our vertex. It's telling us how it's going to be translated. And here, my H is a 2. But see, it says it's a positive 2. So I have to ask myself, what did I plug in here into that negative H to equal a positive 2? Well, I had to have plugged in a negative 2. Negative times a negative gives me my positive. So every time I see that this has been switched, the sign from the original formula, then I know that it was inputted a negative value. So I get negative 2 and then 0 for my K because there was no value there. So let me break this up. Again, I like to color code. I'm a very visual person. So H was a negative 2. K was a 0. I just plugged that in because there's no value there written in. Okay, so what does this mean? Therefore, make sure I spell it right. The graph will be translated. Now remember, translate means slide. 2 points. Well, if it was negative, that means we're going to go left. Oh, I said points. We should say units, right? Units. Left with a 0 climb. So it means we're not going to climb anywhere. It will stay on the x-axis. All right, let's break this up here. So H is pink. That tells me 2 units left. Oops. And my K tells me, that's my vertical, walk before I climb, 0 climb up or down. So let's go ahead and graph our parent function. Oh, no, I already got my parent function. Let's graph our new function here and see what that is going to look like. So I start at my origin and I'm going to walk -2 this way and climb 0. That is my vertex. And then it is going to open down. It should be a little bit wider than my parent function. This is just kind of a rough draft of that graph. I'm going to go ahead and add, there's my vertex with my slope of that -1/2.